All right, guys and gals, let's look at the area of a triangle. You should know that the area for a triangle is area equals 1/2 the base times the height of the triangle. So look at this diagram over here. It's B is for our base and H is for the height. Now you could use any side. You could use C or A as long as you have a perpendicular line to it for your height. Now, you're used to doing with right triangles with area, but what if we don't have a right triangle? You got the tools to take care of that. If we look at this particular triangle right here, sine of C, well, here's C. Sine is opposite, which would be H, we'll look at the right triangle, over A. You know, some old hippie called another hippie tripping on acid, the basics. Rearrange that a little bit, multiply both sides by A, and we get that H is equal to A times the sine of theta, or C in this case, sorry. And if we plug that in, B is B, H is A times the sine of theta, whatever angle you got there. And the area is now going to be 1/2 base times, instead of H for height, A sine of theta. I'm going to use theta. Let's call this angle theta right here. Yeah, that'll fix everything. So for the area of the triangle, what you need is a side, angle, side triangle. You need to know all that information. You got a side, two sides of the included angle, you got yourself the area. Now we just learned laws of sines and cosines, so we can make that happen. Let's see how that works. I do every other one of these probably. So right here, this is already side, angle, side. So we're good. Let's do it. So our area formula is 1/2. Let's see, our first side is 15 times. Our second side is 12. And then sine of the angle in between them. Well, type that in the calculator, round to the tens place, and see what happens. 1/2 times 15 times 12 times the sine of the angle in between them. And we get 84.6. Now we do have units here, it's centimeters. So this is going to be in centimeters squared. 15 centimeters times 12 centimeters makes centimeters squared. The rest of these are just unitless numbers. That's it. Easy, right? Okay, side, angle, side. So we use these three pieces of information, not the 8.4. We don't use 8.4 because that's not, one of the sides that has the included angle. So to set this one up, 1/2 6 times 8 times sine of 72. And whatever that is what it is. Let's see, 6 times 8 times sine of 72. And that'll give us 22.8. Units are meters, so that's going to be square meters. It is area, by the way. So we have square units to deal with. This one, same thing, side, angle, side. This one, same thing, side, angle, side. Oh wait, we don't know this angle, but we know the other two. How many degrees in a triangle? 180. So if I take 81 plus 43 plus this angle theta, we know that's got to equal 180. So I do some basic arithmetic and a little bit of algebra. 81 plus 43 is 124. 180 minus that answer is 56 degrees. So we're done, right? Move on? No. That's what theta is. Now we have two sides and the included angle. Use it. Area is 1/2 34 49.2 sine of 56. Type it in. And we're going to get 693.4, whatever the heck you say. That unit is going to be square feet. All right, so let's see. Let's get some more interesting ones here. This one, same thing. You can find out that angle, and then you're going to have a side angle side. I'm not going to do every problem. This is pretty basic stuff here. Should be able to get it. This one, same thing, but it's not. I don't have two angles, do I? I only have one angle. I need this angle right here. So how can I do that? What have we been talking about? We've been talking about laws of sines and cosines, right? So I have the angle and the opposite side. So I know I'm going to use law of sines. Now, I can't get this theta directly, so I'll call this x. I'll get that as an intermediate value, whatever. So I'm going to solve for x, then use x to solve for theta, and then use that to find the area. Let's follow the puzzle pieces. So for x, that's an angle, so I'm going to say sine of x over 7 has to equal sine of my angle is 93 over 12. We get sine of x is some number. Let's find out what number. Sine of 93 over 12 times 7. Let's multiply both sides by 7. That'll get us this decimal. Don't really care about it, but I'll write it down anyway. 0.5825. What I really need is x. It's going to be the sine inverse of that answer. 35.6. Okay, I'll write that down. X is 35.6 degrees. But is it? It's not exactly that, is it? I am perfectly fine if you round it there and use that rounded answer to get your final area. In fact, I'm going to do it two ways. I'm going to use the rounded answer, and I'm going to use the actual whole dang number and see how big of a difference it is. I don't even know off the top of my head. We'll find out if it makes a difference or not. So to save this, I'm going to shift RCL and then pick a letter. That's the first number I'm going to be saving a couple. I'm going to say this one is A. So now if I recall A, I just type alpha and then A, I get that number back. Okay. Well, I know there's 180 degrees in a triangle, so if I add these two up and take that number from 180, I should get theta. So this number plus 93 is that, sure. 180 minus that answer is 51.4. So theta is about 51.4. And you can see if I do the same thing, I'll do it in a moment, but let me save this first. Shift, recall, and now I'm going to call that B. If I were to do 93 plus this 35.6, take 180 minus that answer, you'll see we get the 51.4. The actual value is 51.37, et cetera, et cetera, et cetera. Calculator stores like 52 decimal places. You just don't see them all. So this is the more accurate answer. So again, it's not perfect because calculators do round, but it's pretty dang close. Closer than we need. We got theta. What are we trying to find again? The area. Let's find it. I now have side, angle, and side. So my area is 1/2 7 times 12 times sine of 51.4. Now we get the rounded answer, rounded, and the, I don't want to say actual, best estimate, I guess. Again, you don't need to do this. I'll take either one of these answers perfectly fine. I just want to see if they're actually even remotely different. We're going to round to the tenths place, and we're going to see if that makes a difference at all. I don't know. So 1/2 times 7 times 12 times sine. I get the rounded answer first. I'm going to type in the actual 51.4. Let's see what happens. And I get 32.8. That's not it. 32.8 square feet. So if you recall, this 51.4 number, I stored that to B. So what I'm going to do now is 1/2 times 7 times 12 times sine of, and we're going to type in the B. Let's see if it makes a difference. 32.8. It does not. So rounding the tenths place makes no difference whatsoever in this particular problem. Probably if these were bigger numbers, it would make a bigger difference. So you might get a tenth off, or maybe even 2/10. But it's not going to make that big of a difference. So if you want to round up in here, that's perfectly fine by me. That's what I'm going to do. If you want to use the exact answer, feel free to use the store function. Go for it. All right, let's see. Is this one any different? I have one side. Yeah, it's different. And I can either do this, or I could do, I could use that angle and get that side. Well, let's see what's easier to find. Doesn't make a difference at all. We got the opposite angle for both of those. We have the opposite angle for this side. We have the opposite angle for this side. So we can do it either way we want to. Literally pick. It doesn't matter. I'm going to do this guy right here. So that's how I wrote it the first time. So I need to find out what this side is. Well, do I know an angle on the opposite side? No, wait, yes I do, don't I? I know two angles, I know all my angles. 28 plus 114 gives us 142. So 180 minus that's 130 is 38. So this angle right here is 38 degrees. So now I have my angle in the opposite side, so I can use it. Again, I'm going to find this one. You could have found that one. You'll get the same result either way you do it. I'll call that one x. So x is a side in this case over sine of the angle opposite of it is 28. Has to equal 20 divided by sine of sine of 38. We need that 114 to figure out what the 38 is, but we don't actually use it right here. If we're calculating this side instead, we would use the 114. Again, either way you want to go. So now we can type that in the calculator and see what x is. 20 over sine of 38 times sine of 28. That gives me 15.3. And yes, I'm rounding again. This one will probably make a bigger difference, but again, whenever we round at the end, it probably won't be too terribly different. I'll find out, just for you people. So now I have that whole number that I can store as A. So area, we got the information, side and angle on the side. Half 20 times 15.3. Again, I'll round it first and then see what happens if I don't round it. Sine of the angle between it is 114. Here we do use that 114. Type it in, see what happens. Rounded version. And we get 139.8 square inches. Again, I'll redo that, but with the exact, well, not exact because it's still rounding, just like 52 decimal places worth. If I do that, I get 139.3. So this one does make a few decimal places difference. It's a whole half a unit. So to be exact, you don't want to round until the end. I will take either way. You can give me this, you can give me that. I'm good. Okay. Same thing as the previous one. We have to find a missing side. So these two are the same. Here we go, something different finally. We have three sides. We do not have the angle. So for law of sines, I need an angle in the opposite side. I don't have that. What can I do? You're right, law of cosines. So pick an angle. Eeny, meeny, miny, freaking mo. It does not matter. I'm gonna go with this one because it's in the top left. It makes like the eyeball. Just pick one, doesn't matter. So if I'm using this angle, if I'm solving for that angle, I'll be using these pieces of information. I need to start my law of cosines with the side opposite of my angle, so 23. And then the order of the other two does not matter. Multiplication is commutative and addition is commutative. Cosine of my unknown angle. Or if you're using the law of sine, if you're using the law of cosines to find the side, you can type all this in at once. We're not, we're looking for an angle. So we have separate pieces of information here. These are like terms, but this over here has a cosine of theta on it. So you cannot combine this piece with that piece. Instead, we're going to bring this over to the other side. So let's use our calculator. 23 squared is 529. Equals, these two I can put together, so I'm just going to type it in a calculator together. 15 squared plus 21 squared. Okay, 666. This is going to be a negative 2 times 15 times 21, 630 cosine of theta. So we combine like terms, that's going to be 36 cosine of theta, right? No, these are not like terms. Don't try and combine them. I don't know why people always try and combine them. You can't do it. It's got a variable on it. That'd be like saying 3 plus x is 3x. Okay, y'all do that sometimes too. Never mind. Anyway, get this to the other side. Subtract 666 from both sides. Let's see what happens. 529 minus 666 is negative 137 equals negative, don't forget your sign, 630 cosine of theta. Okay, then to get cosine of theta by itself, we're going to divide both sides by the coefficient here, negative 630. Type that in your calculator, let's see what happens. Negative, I don't want to do that. Negative 137 over negative 630 gives me, okay, 137 over 630. That's what cosine of theta is equal to. Sure, why not? I'll write this stuff out. So to get the angle, I need to take the inverse cosine of that. So shift, cosine, answer. Or you could have done 137 over 630, doesn't matter to me. 77.4, either way you do it. Again, you can type, you can store that to A or something if you want to. I'm not gonna. 77.4 is theta. Now we have the angle and the two sides and the angle between them. Make sure you know which angle you picked. If you started with 23, you got this angle. If you started with 15, you got that angle. If you started with 21, you got that angle. Whatever way you do it doesn't matter. You'll get the same area. No, I'm not doing it multiple times. But if you do, you're going to use half times 21 times 15 sine of 77.4. Yes, it's still sine. Just because we use log cosines to do something else doesn't mean we switch to cosine. Area is 1/2. Completely forgot the numbers. 15 and 21. Sine of that 77.4. Technically, since you have it right here, you could just do sine of your answer at the end, but oh. Half times 15 times 21 sine of 77.4. I'm going to round. 153.7. That is millimeters. Let's do square millimeters. And that's it for that one. That's about as complicated as this will get. Really, I can't see it. There's no way to make it complicated. It's not complicated to begin with, right? You just got to make sure you got side, angle, side. What you do, plug them in the formula. Let's see here. Same thing. Am I going to do it? No. That's the last one for area. All right, guys. That's it. See ya.